What is load balancing? Load balancing is the capability of a router to distribute traffic and use multiple paths to a destination when forwarding packets. And why would you want to do that? With load balancing, you can increase the utilization of network segments and with that, increase the effective bandwidth. Sounds like a desirable feature, right? Now let's look at an example. If you take a look at this topology, there are two layer 3 paths from network A to network B. It is a common customer expectation that if there are multiple devices and paths to a destination, all paths should be utilized. If the paths to a destination have equal costs, traffic gets load balanced by default. This statement is valid for all routing protocols, not just EIGRP. For instance, if the metric to get from the router on the left, that's R1, to the router on the right, which is R2, for both paths equal 100, then traffic will get load balanced between the two interfaces on router R1. This means that in theory, some traffic will be sent from router R1 to router R2 using the interface Gigabit Ethernet 0/0 as the outgoing interface, and some traffic will use the interface Gigabit Ethernet 0/1 as the outgoing interface. So we could say that equal cost load balancing is the ability of a router to evenly distribute traffic all over its network ports through links that have the same metric from the destination address. By default, Cisco iOS software applies load balancing across up to 4 equal cost paths for a certain destination IP network if such paths exist. But how about if you want to change this behavior and put more than 4 equal cost paths to the routing table? With the maximum paths router configuration command, you can specify the number of routes that can be kept in the routing table. The maximum paths command is entered in the routing protocol configuration mode, in this case in EIGRP mode. In the example, the Cisco router supports up to 16 paths. If you set the value to 1, you disable load balancing. Now EIGRP can also balance traffic across multiple routes that have different metrics. However, you need to be aware that this feature is not enabled by default. In this example, there are two paths between router R1 and router R2. By default, all traffic will select the better path, which is the lower path because of the lower metric. Remember, only equal cost paths are entered into the routing table. You can change this default behavior for EIGRP using the variance command. You can use the variance command to tell EIGRP to install routes in the routing table as long as they are less than the current cost multiplied by the variance value. So the current lowest metric to get from router 1 to router 2 is 25. If you use the variance value of 4, traffic will get load balanced across all links for which the metric is lower than 100. The metric for the upper link is 90, so less than 100, which means that from now, traffic will get load balanced across these two links. This is called unequal cost load balancing because traffic gets load balanced despite the fact that there are two paths with different metric values. This way, the backup link actually gets utilized.